On our nomenclature grid, polyatomic acids fell into quadrant 3. Now, most polyatomic acids are just memory acids. That's the bad news. Worst news is there's literally hundreds of acids. Well, you don't need to memorize them all. All I want you to do is memorize 7 of what is known as ic acids. So let's go over those. Sulfuric acid, H2SO4. Nitric acid, HNO3. Phosphoric acid, H3PO4. Acetic acid, C2H4O2. Brief disclaimer, it's sometimes written differently because one of those hydrogens acts very different from the other 3. Chloric acid, HClO3. Chlorine is a halogen. Bromine and iodine are oftentimes included right beside that because they're all halogens, they have very similar acids, and they have very similar properties. Next is carbonic acid, H2CO3. And finally, chromic acid, H2Cr2O4. The only way you're going to know those is to memorize it. So this is one of the few times I would actually recommend you using flashcards or whatever it takes so that you can very, very quickly recognize the names when you see the formulas and the formulas when you see the names. It was good news knowing that we only have to memorize 7 of the hundreds of polyatomic acids. And it's also good knowing that there are a number of derivatives of those polyatomic acids that don't have to be memorized either. They can be determined by considering the polyatomic acids to live in families. So, let's consider sulfuric acid and let's determine who its family members are. Here we go. Some ic acids, and we know this first one is sulfuric acid. How do we know that? Memory. But once you have that, there happens to also be a family member that looks exactly like sulfuric acid, only it has 1 less oxygen. It has 3 instead of 4. And we're going to name that sulfurous acid. It's very similar chemically, and we're going to have a very similar chemical name. We're just going to change the ic to us. So it now becomes sulfurous acid. Now, what do acids do for a living? Well, for the most part, they give up hydrogens. They give up protons. So let's see what happens to sulfuric acid when it does its job. It gives up 2 protons, and we're left with SO4. It's just the formula with the hydrogen scratched off, as it were. Now, because we lost 2 hydrogens, we have to give this a -2 charge. And this is called the anion. Sulfuric acid will produce some anion. We need to name it. We're also going to name it as a derivative. And so we're going to call that sulfate ion. So in this particular case, we're just going to change the ic to 8. Well, wait, you say sulfurous acid is an acid, so shouldn't it give up a proton? Indeed it does. It's going to go to SO3, and because we're giving up 2 hydrogen, it's -2. And we need to give this a name. Well, we can't name it sulfate because that name is taken. Let's name it sulfide. No, we can't do that because when an element goes to a charge, that's where the ide ending is used. Well, what are we going to give it? We're going to call it ite. Just by convention, when us acid loses its protons, it's called sulfite. And so now you can see the relationship between all of those. You memorize the ic acid, and you can calculate the other family members. Now, just as in the real world, not all families are the same size. Some are larger, some are smaller. There's 3 of the 7 memory acids that I gave you that I refer to as orphans. They really have no family. It's just the ic acid and its associated 8 anion. So now recall, H2CO3 is carbonic acid. And so what's its sibling called? Well, we're going to get rid of the 2 H's. So we're going to be left with CO3. We lose 2 protons, and we're going to name that, well, we know it's going to end in 8 because ic acids go to 8 anions. So it's going to be carbon 8. You might have even heard of carbonated water before. Notice that there are no other family members but these 2. How do you know if something has a normal family or an extended family or they're orphans? That too is memory. So you'll need to put these 3 to memory. So let's look at a table that lists our 7 memory acids. You can see that nitric acid has 4. You can see that sulfuric acid, which we did, you can see that those 4 members. You can see that acetate and carbonate and chromate, they're orphans, are only a pair in the family. Oh, but what about chloric acid? Oh my goodness, it looks like there's 8 members. It has an extended family. Well, it could take a while to explain that, so we're going to cover that on another video. But what you need to know at this point are a few things. You need to memorize your 7 ic acids. You need to know that once you've memorized the ic acid, you're going to have at least 1 more family member, but you might have several more. And you need to know that if the anion results from an ic acid, it's going to take an 8 ending. If it's derived from an us acid, it's going to take an 8 ending. And as a reminder, if you turn an element into an anion by gaining electrons, that will take on an ide ending.